All right, let's look at some of the specifics on supply chain management software. An essential element of a capable supply chain information system is the software applications that help managers arrange, analyze, and act upon relevant data. The supply chain software market includes technologies that address virtually every activity that occurs in the supply chain. Whether a company needs to develop a sales and operations plan, analyze facility relocation options, or maintain visibility of inventory, relevant software is available. Supply chain software applications harness the computational power and communication abilities of an SCIS to help managers make timely, appropriate decisions. The primary SCM software categories include planning, execution, event management, and business intelligence. Supply chain planning applications help organizations evaluate requirements for materials, capacity, and services so that effective fulfillment plans and schedules can be developed. The tools help managers gain accurate, detailed insight into issues that affect the development of supply chain processes. The solutions use complex algorithms, optimization techniques, and heuristics to solve supply chain objectives within the stated planning horizon. Today, supply chain managers need to understand omnichannel demand, forecast at a granular level, and manage resources across multiple supply chains. These needs would be well served by a robust supply chain planning suite. This integrated collection of software sits on top of a transactional system to provide planning and what-if scenario analysis capabilities. Use of execution tools is extensive due to their rapid ROI, or return on investment, and positive impact on supply chain performance. Companies deploy a variety of execution software to implement their strategies and manage supply chain flows of product, information, and money. Effective integration of these tools support data sharing and cross-chain visibility. The most widely used execution software include the warehouse management systems and transportation management systems discussed in previous chapters. However, the category has greatly expanded as companies seek integrated fulfillment capabilities. Supply chain event management tools collect data in real time from multiple sources across the supply chain and track the inventory as it flows through the supply chain, providing graphical displays of expected and actual inventory levels and other key data at each location. As the geographic scope and number of companies involved in a supply chain grow, the ability to monitor activities exceeds manual capabilities. Business intelligence software supports self-service reporting, performance scorecarding versus goals, development of graphical dashboards, and activity monitoring in support of event management. These business intelligence tools also provide access to data residing on multiple SCIS without the need for technology department involvement. Hence, cross-chain collaboration is supported. Emerging business intelligence goes well beyond descriptive information on past performance. These big data capabilities are more dynamic, allowing managers to deploy diagnostic, predictive, and prescriptive analytics for greater value. Briefly discussed here are systems and applications that provide critical links between supply chain processes, the organization, and external stakeholders. Collectively, they create a holistic view of the supply chain. Let's look at enterprise resource planning. ERP systems incorporate internal and external systems into a single unified solution that spans the enterprise. ERP systems include the software that support business functions and processes, computing hardware for hosting and executing software applications, and back-end network architecture for data communication across and within information systems. A centralized and shared database system links the business processes, allowing information to be entered once and made available to all users. Supplier relationship management. SRM is a controlled and systematic approach to managing an organization's sourcing activities for goods and services. SRM seeks to improve communication with suppliers by establishing a common frame of reference for the organizations. SRM software supports the effort by facilitating design collaboration, sourcing decisions, negotiations, and buying processes. SRM, or Supplier Relationship Management Software, also helps organizations evaluate supplier risk, performance, and compliance throughout the life cycle of a contract. The goal of SRM and related software is to consolidate processes, streamline transactions, and improve information flows so that costs can be reduced and the end product for the consumer can be improved. Customer relationship management, or CRM, focuses on the practices, strategies, and technologies that companies use to manage and analyze customer interactions and data throughout the relationship lifecycle. CRM software consolidates customer information in a database so business users can more easily access and manage it. The system serves as a vital nerve center to manage the many connections between sellers and buyers in a supply chain. It facilitates information sharing and accessibility. Let's look at automatic identification. Supply chain managers can deploy a variety of automatic identification, or auto ID, and data capture technologies to assemble accurate data for analysis, planning, and execution of key processes. These technologies include barcode labels, radio frequency identification, RFID tags, optical scanner recognition tags, and related hardware and software. They work together to recognize objects, collect relevant information, and feed the data directly into the SCIS. Auto ID tools enhance the visibility and control of products as they move across the supply chain. Let's look at some supply chain management technology implementation. As indicated, a wide array of software tools support supply chain planning, execution, and control. Companies spend billions of dollars on these technologies with the goal of making their supply chains more productive and effective. The key to overcoming these issues and harnessing the capabilities of supply chain technology within a reasonable time frame is informed decision making. The most important step in software selection and implementation is to understand the supply chains that the technology is intended to support. Too often, supply chain managers undertake the software selection process in isolation and without knowledge of the processes to be automated. Organizations must start with a diagnosis of their situation. This needs assessment sequence highlights the link between effective business processes, appropriate technology, and supply chain performance. Supply chain managers face a multifaceted decision when selecting supply chain software. The manager must determine which type of software, planning, execution, event management, or business intelligence, is appropriate for the given process or situation. They must develop alternatives, they must look at solution packages, and they must decide on purchase options. Supply chain managers tend to focus on functionality when considering software, but they must also consider the implementation and operational issue. Potentially useful software will become shelfware if it's difficult to install, poorly linked to other tools, or too cumbersome for use. Supply chain technology buyers need to understand the challenges of application integration while pursuing improved SCIS connectivity. They must assess and compare integration methods and then choose those that best fit current needs while providing the flexibility to meet future functionality requirements. They would do well to follow these 10 golden rules for success. Secure the commitment of senior management. Remember that it's not just an information technology project. Align the project with business goals. Understand the software capabilities. Select partners carefully. Follow a proven implementation methodology. Take a step-by-step approach for incremental value gains. Be prepared to change business processes. Keep end users informed and involved. And last, measure success with key performance indicators. Let's look at some supply chain technology innovations. If there's one constant in supply chain management, then it has to be ongoing change. That may seem like an oxymoron, but the discipline is continuously evolving to support omni-channel innovation, global network realignment, and customer service enhancement. To achieve success, supply chain managers must effectively leverage current and emerging technologies. Well, let's think about the Internet of Things. connected devices with sensors, on-off switches, and internet linkages already outnumber the world's population, and the gap is accelerating. The broad range of the Internet of Things business equipment, devices, and mechanisms is already in use. The technology will allow supply chain managers to intelligently connect people, processes, data, and things using Internet of Things devices and sensors. This deeper intelligence will be used to align, synchronize, and automate supply chain activities. A number of security issues must be resolved to bring Internet of Things to its full potential. Increased digitization of information and transfer via the Internet creates data theft risk. Remote tampering with physical infrastructure is possible, and consumer privacy must be protected against data breaches. To avoid such problems, Internet of Things users must identify their risks and take meaningful steps to mitigate them. This includes reducing the amount of data collected by Internet of Things devices, deploying layered security systems, including firewalls, intrusion detection systems, and antivirus tools, segmenting networks, and allowing people to opt out of Internet of Things initiatives as desired. Although mobile connectivity is growing, it has not reached the saturation point in the marketplace. Opportunities for wider adoption are vast as mobile technology problems have faded away. Price points for hardware and communication have fallen, the reliability of mobile technologies has greatly improved, and logical solutions with real ROI are being developed. Mobile connectivity is critical in the transportation area, as freight companies must grapple with the competing objectives of maximizing service and minimizing costs. They need a continuous link with their geographically dispersed drivers, equipment, and cargo. Enhanced geographic information systems data, along with real-time and predictive traffic data, are needed to effectively plan routes, determine dispatch time, and reroute in-transit freight. These capabilities will help the freight companies to accurately predict arrival times, reduce delivery costs, and decrease energy consumption. Warehouse operations have long relied on RFID-enabled terminals on forklifts and handheld devices to direct employees' activities. Yet traditional labor management systems are PC-based and tie managers to the office. They need to spend more time on the warehouse floor to gain operational oversight and coach employees, according to a recent survey. Mobile technologies and solutions will provide managers with access to critical productivity, workload management, and exception data regardless of their location. Such capabilities will allow managers to break away from the office and spend much needed time directly engaging with their employees and improving throughput. Mobility is also a technology priority for manufacturing operations. Forward-thinking manufacturers are integrating mobile capabilities into their quality systems. This allows real-time monitoring of supplier traceability, quality, and non-conformance and corrective actions. Mobile integration of dashboards on mobile devices will allow managers to monitor production workflow performance. The goal of these initiatives are to make manufacturers more responsive to customers and make manufacturing intelligence the new normal in production operations. Automation has long been a part of the manufacturing plant, with conveyor moving products between workstations and robots handling welding, painting, and other precision tasks. Warehouse automation has also gained tremendous traction as companies are opening large-scale distribution centers that deploy automated storage, handling, and distribution technologies rather than manual labor. Fulfillment speed and accuracy, two essential elements of omnichannel retailing, are greatly enhanced, and there is never an absenteeism issue. In contrast, the transportation function continues to be a labor-intensive activity, particularly the trucking industry. Connective technology needs to support driverless vehicles. Connected technologies needed to support driverless vehicles are under rapid development. Daimler's Future Truck 2025 navigates using its highway pilot system, enabled by a collection of cameras and radar sensors, while continuously transmitting its position to other drivers and traffic control centers. The pilot program puts a driver in the vehicle to handle driving on city streets. However, it relies heavily on the operational system for highway driving, much like an autopilot system for an airplane during normal flight operations.